Hi guys, this is Miss Messer. Hope you're having a good week so far. This is your last task for this week, so you have a video to watch with some notes and then just a couple problems to practice. Make sure that if you have any questions or need any extra help that you're checking out your teacher's office hours this week and joining the Google Classroom Hangout so that you can ask those questions. Okay, so let's go ahead and get started. Today we're going to be talking about transformations of linear functions. So we're basically going to be taking a line and moving it. We're going to move it up and down. We're going to shrink it. We're going to stretch it. And we're going to change the slope. Okay, so those are all the different transformations that we can do. And then we can also do more than one transformation at a time. So when we get to the end, we're going to combine some of the transformations that we've looked at. Now, in order to have a transformation, we have to know where we're starting. And so where we're starting is called the parent function. This is our parent function for a linear function. Okay, and basically what a parent function is it's just the most basic linear function that you can have. Okay, so if I was going to draw the most basic straight line, this would be it. Okay, in order to take these notes today, I want to make sure that you have a piece of paper and a pencil. And so if you need to pause this video to grab your supplies, do that right now. And then we're going to get started with this first problem. Okay, hopefully you have everything you need. Feel free to pause as we go because you do not have the table already started like I have, or you don't have the graph set up like I have. And so as we go through, if you need to pause to kind of catch up, feel free to pause this video. All right, so we're going to look at this parent function so we can see what the most basic linear function looks like. So what I'm going to do to fill in my table is I'm going to plug in the values that they give me for x so that I can tell what my y values will be. So if x is -3 and I plug that in, then this tells me y is also -3. Y equals -3. Okay, if I plug in a -1 for x, then y is -1. And that continues all the way down. Whatever the x value is, the y value is going to be the same in this parent function. Okay, another way to do this, and you could pause if you want to get this set up, is you could open the calculator app that we sent you earlier this week. And this is just like the calculators we have in class. So you can go to the y equals button and you can type in this function right here. And when you type that function into y equals, you can hit second graph and you will see the table and you can just fill in the table. Okay. So now I'm going to take these points from my table and I'm going to plot them on my graph. Okay. So the first one is -3, -3. So that's right here. And then I have -1, -1. Then I have 0, 0. And then I have 1, 1. And then I have 3, 3. Okay, so you can tell that's close. It's not perfectly straight. And then I'm going to draw as best as I can a straight line through those. Okay, so that is my most basic linear function. It's the parent function. Okay, and so there are no transformations here. The transformations are none. Okay, so now let's take this and let's do a transformation to it. Okay, so now we have our parent function and we're subtracting 5 from it. Okay, so my first transformation is adding or subtracting. And let's see what that does to my table and my graph. So I'm going to give you the points. I'm going to assume that if you want to do this with me, that you'll pause the video, put it in y equals, fill out your table, and plot your points. So I'm going to go ahead and just do that. I'm going to pretend that I've already done that because I don't have a way to show you my calculator on this screen. Okay, so I've already figured out my table. So I have -8, -6, -5, -4, and -2. And so then I'm going to plot those points. So -3, -8 is right here. -1, -6 is right here. 0, 5, -5 is right here. Oops. There we go. And then I have 1, -4, and 3, -2. Okay, so I'm going to again connect those as best I can. All right, you're going to notice, if I go back, that is the same line that I just saw, but it's shifted down, okay? Notice my parent function crosses at 0, 0, right here. That's its y-intercept. And now I'm crossing at 0, -5. My y-intercept has shifted down 5. And so what I'm going to say for my transformation is that it is a vertical shift down 5. Okay? And we call that a translation. Okay? But I'm okay with you putting vertical shift down 5. All right, let's look at another one. All right, so this time I'm have my parent function and I'm multiplying by 3. Okay, that's going to be my transformation. So my parent function is y = x, and anything added to that, anything you see being done to the x is the transformation. So I see that the x is being multiplied by 3, so that's going to change my graph. Okay, I'm going to again give you the table values. So I have -6, -3, 0, 3, and 6. And again, if you don't understand how I got these, you can either plug in -2. Okay, so let's say that I have y = 3 and I want to know what the value is for -2. I plug in a -2. 3 times -2 is -6. And so that's where I got my y value. You can also put that in your calculator. Okay, I did this ahead of time. So now I'm going to plot those points. So -2, -6 is here. Oops. Then I have -1, -3. Then I have 0, 0. Then I have 1, 3. And then 2, 6. All right, I'm going to connect those. It's not perfect, but that's okay. All right, so the first 2 graphs that we did were the same line, just shifted up and down. So let's take a look at those. So there's that line. What do you notice about this line? Do you notice that it's steeper? Okay, and so this is going to be a stretch or a shrink, and it's hard sometimes to remember whether it's a stretch or a shrink. And so what you're going to do is, if it's steeper, I think that I'm stretching up to get a book off the top shelf, okay? So it's like a ladder that's steeper so that I can reach the top shelf, okay? So I'm stretching to the top shelf. So we're going to call this a vertical stretch by 3. A vertical stretch by 3. Okay, now I'm going to come back to this page in just a minute after we do a vertical shrink. And we're going to have a little note here so that we know what kind of number gives us a stretch and what kind of number makes our graph shrink. Okay, so here's our next one. Again, I'm going to give you the values. So if I plug in a -6, I'm going to get -2, -1, 0, 1, and 2. I'm going to plot those points. So -6, -2, -3, -1, 0, 0, 3, 1, and 6, 2. Okay, what do you notice about this particular graph? Right, it's less steep than our original parent function. Okay, so from our parent function of y = x, this is less steep. Okay, so this is a vertical shrink. Now, we do not say that it's by 1/3. We're actually going to use the reciprocal and say that it's a vertical shrink by 3. Okay, so what do we notice about a stretch and a shrink? The first thing about a shrink is that we use the reciprocal to name it. Okay, and then we're going to notice that anytime we have a fraction or a number less than 1, so if my number is less than 1, it's a shrink. And if I go back a page, if my number is greater than 1, it's a stretch. Okay? If it's less than 1, or if it's between 0 and 1, really. If my number is between 0 and 1, let's see. So if my number is between 0, and 1, then it is a shrink. Okay? Because we're not talking negative numbers. Negative does something completely different. Okay? So let's look at what negative does. All right? So far, let's review. We know that negative, subtracting a number is a vertical shift down. So we're going to assume that adding a number is a vertical shift up. We know that multiplying by a number greater than 1 is a stretch. Multiplying by a number between 0 and 1 is a shrink. So then let's look at what happens when we have a negative number, okay? So again, I'm going to fill in this table. I get the same number, but just the opposite sign with this one. So I'm going to plot those points, -3, 3, and then -1, 1, 0, 0, 1, -1, and 3, -3. Okay, something like that. It's not perfect. Okay, and then what we notice about this one, if I had done my line a little better, is that this changes our slope. Okay, so this is going to be a reflection over the x-axis. Okay, so I basically am flipping this over the x-axis. Okay, it's going to change my slope from positive to negative for linear. Okay, so we have a vertical shift up, a vertical shift down, a stretch, a shrink, and a reflection over the x-axis. Okay, so let's look at this last one. This last one, I see multiple transformations in this particular function, okay? And I'm gonna kind of show you each one that I see. So I see that we're subtracting 5 from x. I see that we have x being multiplied by 3, and I see that we have a negative right here. Okay? So, if you notice each one of those, I'm actually going to undo that so that you can see the original function again. All right, so if I was going to plot my points, I would use these numbers. Again, I can get these on my graphing calculator, or I can plug in x values and solve for y. Okay, so I'm going to plot my points. -4, 7. -2, 1. -1, -2. 0, -5. And 1, -8. Okay. Now, this one it may be hard to see what's happening by the picture. However, because I've done so many transformations, I know that subtracting 5 from x is going to be a vertical shift down 5. I know that multiplying by 3 is going to be a vertical stretch by 3. And then I know that a negative sign is going to be a reflection over x-axis. Okay, so I had 3 transformations, and I'm going to list them all there. Okay, so I want you to take a minute and do one on your own. So if you'll take a look at this one and pause the video, you'll notice that I didn't give you a table and a graph, because by this point, I'm hoping that you don't need to see the picture or see the table in order to know what the transformations are. So pause the video right now and work this one out. Okay, hopefully you've worked it out by now. I see how many transformations? Yes, I have 3 transformations. So I have a vertical shift. The +7 is a vertical shift up 7. The positive means it goes up. Okay. The 1/5, is that a stretch or a shrink? Good. It's a shrink because that number is less than 1. So this is a vertical shrink by, and then I don't say 1/5, I flip it. I say 5. A vertical shrink by 5. And then the negative sign is a reflection over x-axis. Okay. All right. So you have a few problems to work today, and it should take you less than 10 minutes. So you should still be well under your 30 minutes for today. I hope you have a great weekend. There's no work for tomorrow because it's Good Friday. So we technically have the day off of school. So I hope you have a great weekend. Happy Easter. I hope you and your families are able to celebrate and have some good family time. And I will see you Monday.